This video is on putting quadratic functions into vertex form by completing the square. You may want to review the video on completing the square for circles to put them into center radius form to refresh your memory on the completing the square process. There are some new twists, though, for quadratic functions into vertex form. So first, we'll just remember from the other video that vertex form is y equals a times x minus h quantity squared plus k. So first, we'll go with y equals x squared minus 6x plus 9. We want to put this into vertex form. So we need a perfect square, and fortunately we have a very nice function here because when we factor it, it factors as a perfect square. X minus 6x plus 9 is x minus 3 quantity squared, which is kind of nice. We are already done. And the vertex, remember the vertex is hk, and this is x minus h. So the vertex is 3, comma, well, there is no k, so the y-coordinate of the vertex is 0. Next, let's do a related one. X squared minus 6x. Now, I don't have a constant term here. I could factor out an x if I were interested in a factorization, but I'm not. I'm only interested in things that factor as perfect squares because, well, that is what vertex form is. That's my goal. So here, I can add in a 9, but I can't just add in a 9 because I don't want to change the value of the function. But if I add in a 9 and subtract a 9, really, I've got a fancy form of adding 0 there. So I haven't changed the value at all. And this part right here is my perfect square. That's x minus 3 quantity squared. And then I have a minus 9 on the outside. So for this one, my vertex is 3, comma, negative 9. Next, we'll do one more related one. I'll have x squared minus 6x plus 117. So now, there are a couple of different ways I can approach this, but I really want to think about it as similar to number 2. I've just got this 117, so for my first step, I'm going to shove that out of the way. And now I'm going to do the exact same thing that I did by adding in a 9 and subtracting a 9. That way I'm just adding in a fancy form of 0. This is my perfect square. And that factors as x minus 3 quantity squared. And then I have these two numbers on the outside. I can combine my like terms there and add up and end up with plus 108. So next, I'll push the paper up a little. And let's have a different problem. Remember from the completing the square for circles, in order to find this number, you always want to look at the coefficient of x, which is negative 6, take half of that, which is negative 3, and square it to get positive 9. That's how I know what number needs to be added in order to complete my perfect square. So here I've got y equals x squared plus 10x plus 52. Oh, on the one above, I didn't actually say what my vertex was, which isn't really necessary. I wasn't asked it, but I had done it for all the others, so I'll point out that that vertex is at 3, 108. Now, on this one, I'm going to do the same thing I did above. I'm going to shove over the 52 to get it out of the way. And then I need to figure out what number to add and subtract. I will do that by looking at the number 10. So I'm going to take this, I'm going to take half of 10 and square that. So half of 10 is 5. So that squared is 25. So I get plus 25 minus 25. And now this part right here is my perfect square. That is x plus 5 squared. I know that both because I can see that that's how that factors, and also the completing the square process will always be x plus whatever this half of whatever was. Here we took half of -6 and ended up with x minus 3. Here we take half of positive 10 and end up with x plus 5. I'm not finished on this line yet, though. I need to combine my like terms here, and I end up with x plus 5 squared plus 27. So my vertex for this one is, now remember my vertex form, all up at the top here, is x minus h. So I always take the opposite of what is in the parentheses. So the x-coordinate of my vertex is -5, and the y-coordinate is 27. So now, let's do another one. Let's do like 3 more, but we'll start with this one. X squared plus 3x minus 1/8. So now, I've got a new problem. But the ones that we've done before, when we had taken half of the number in front of x, well, we always started with an even number, so we always ended up with an integer answer. Here we've got 3. I'm going to take half of 3. I'll get 3 halves. And square that. So 3 halves times 3 halves, I'm going to get 9/4. Now, let me go ahead and write this line in. I'm shoving over that minus 1/8. And I'll do plus 9/4 minus 9/4. Now this is my perfect square, and I know that it is a perfect square because I have built it to be a perfect square. It would not be obvious how to factor that necessarily, but since I built it by completing the square, and when I do the completing the square process, my perfect square always factors as x plus whatever this half was before I squared it. So I get x plus 3 halves squared. And then I just have to combine my like terms. Now I've got fractions, so I would need a common denominator. This is 9/4, negative 9/4, which would be the same as negative 18/8. So negative 18/8 minus 1/8, well, that's negative 19/8. So my vertex is 3/2, negative 19/8. Oop, oh my goodness gracious, look at that. It is not 3/2. It's negative 3/2, because remember, we always take the opposite of this. So this was positive, and so the x-coordinate of the vertex is negative 3/2. All right, let's do another one with an added twist. Oops. So this is number 6. Y equals 2x squared minus 16x plus 3. Notice I have a coefficient in front of my x squared. This is something that we never had with the circles. So I am going to factor out, remember my vertex form, it can have an a. It can't have anything directly in front of the x, but it can have an a in front of the parentheses. So this 2 is going to become that a. I'm going to factor out, but also notice that I don't need to factor a 2 out of that 3, because that 3 will eventually become part of this k. So I'm going to leave myself some room inside of these parentheses, and then I'll have the k there on the end, or well, the 3. It's not going to be the entire k, but it will go into that k. So now I take half of negative 8 and get negative 4. I square that to get 16. And then I add and subtract 16. This part in here is my perfect square. So now you need to be careful not to drop your parentheses. I have this, and then I factor in, or I factor to be a perfect square, that to be x minus 4 quantity squared. Notice that now I have 2 sets of parentheses. So I need to distribute this 2 to each thing. I don't want to distribute inside my perfect square, but I do want to distribute it in front of my perfect square. And 2 times negative 16 will be negative 32. I still have that plus 3 on the end. And so this ends up as 2 times x minus 4 squared minus 29. Okay. Let's do one more example like that. And that will be y equals negative 3x squared plus 18x plus 1. And so I'm going to factor out the negative 3 from everything that has an x in it. When I factor out a negative 3 here, that becomes a negative 6x. Then I'm going to leave myself some empty room. This plus 1 can stay on the outside. I don't need to factor the negative 3 out of that. So now I take half of negative 6 and square it. I get plus 9 minus 9. Notice that this is my perfect square. Then I factor my perfect square as x minus 3 squared. I distribute this negative 3, so I get negative 3 times x minus 3 squared. Negative 3 times negative 9 is positive 27. Then I have that plus 1 on the outside. And finally, I combine my like terms. And, whoops, almost off the screen there. And there we have it. Completing the square in order to put quadratic functions into vertex form.